Hi, everyone. I think we should be getting ready to start this session, and we are expecting to have Eric Schimmel, Jameson Dungan, Robert Lindemann, and Thomas Chabi, Kendrick Cary, and Cristina Taphouse as speakers for this particular session. They are going to be exploring the amazing world of fungi. And before we get started, I think we would have Derek say something very briefly while we get the speakers join us. Sorry for the delays on this particular one. Let's have Derek share something amazing from the Makerspace.
Well, thanks, Harry. I'm not so sure about how amazing, but I'm really interested in this topic. And one of the things that weaves through a lot of the stuff at the Victoria Makerspace, with Victoria, British Columbia being largely an agrarian community. I mean, it's the capital of British Columbia, but you go 10 minutes outside the city and you're mostly in farms. Is this idea of how biology relates with where our food comes from? And another thing that's huge up here is mycology, and local businesses together with fungi being the topic today. We've had a really interesting line of research going on in our Makerspace for about 5 years now, where we've been doing DNA barcoding of fungi, and we have mushroom shows around British Columbia in the falls. Just as it starts raining, they start popping up everywhere, and it all started when the South Vancouver Island Mycological Society approached us to talk a little bit about mushroom genetics. And we had a member teach a class on how to grow mushrooms, and then got into the barcoding side of things. And was initially quite difficult because mushrooms have chitin that binds with the DNA. And so breaking them out to get access to the 800 base pair barcoding region normally requires a chloroform-based procedure to get that DNA out. And we decided that was a bit cumbersome and dangerous for a community makerspace, not something we wanted to have in our cabinets all the time. And so we did quite a bit of experimenting with different methods of pulling the DNA out, and didn't find anything that worked as well as the chloroform-based solutions, but did find some other approaches that work generally. And consequently, we have been for the last about 3 years kind of an integral part of the mushroom show in Victoria. And I have taken any samples that the experts who identified the mushrooms morphologically at those mushroom shows weren't certain about, and did our barcoding on it, and have found all three situations where we confirmed what the expert had identified it as, where the expert was wrong, and we were able to tell them how they were wrong. And most interestingly to my eye, when we have twice now found species that were not in the barcoding database, and got to bounce that back to the Mycological Society and say, hey, you might have a new species here. And that's been really fun to participate in as well. And so really just by asking the question through barcoding of what's in our environment, we can really start to close this loop of having sound ecological solutions. One of the things that's come out of our makerspace in that regard, also related to barcoding, is a small company that sprung up to do freshwater quality measurement. And they saw what we were doing with DNA barcoding, and they were doing these quality assessments by means of, under a microscope, studying the microscopic organisms that live in the stream. And those are indicators of stream water quality, but they're very difficult to identify. And so they've since also gone to a barcoding approach to try and filter out, crunch up breakout DNA and then barcode to get an idea of what species of small organisms are living in stream water. So all sorts of interesting connections between ecology and makerspaces and things that you can do there. I don't know, I just wanted to kind of talk a couple of those examples as a way of kicking off discussion of what other business-related, ecology-related topics people have going on in their makerspaces.
Great, thank you very much, Derek. I think maybe just while we are with the speakers, we can have some fun conversation about fungi in your, especially for those who are on the call today, who are doing some amazing stuff with in the whole world of mycology and fungi. We want to hear what projects and initiatives that are kicking off in your various biohacking spaces and biolabs. Please, the mic is open for anybody who at this point wants to share some interesting works that you are doing with fungi in your various community labs. Thanks.
So actually, last year I collaborated. There's an organization called Curiosity Collider here in Vancouver, and they've been running these monthly events where it's kind of like an art meets science event, and people go to like a restaurant, they book a space, and it's like a bunch of presentations. So, you know, they charge $10 at the door, and they come in, the restaurant benefits from the food, and you get these amazing mini talks. So last year, they've been running for about 4 or 5 years now. And last year they decided to create their first Art Meets Science Collision Festival. And so they had one of these events where they were trying to get artists to engage and meet with scientists. And so from that, I met an amazing artist who's very much interested in invasive species. Laura Sirman is her name. And she and I kind of collaborated. So I taught her how to do DNA barcoding of plant species. So she was going out and picking weeds, I guess, from around the city, and her travels around the province. And then she learned how to DNA barcode, extract the genomic DNA, PCR amplify up the barcode region, and then we sent that for sequencing. So she has also got a music background, so she used her knowledge of music theory to be able to engage. It will translate the DNA sequence into chords. And any scientist here who's used any of the software tools that where you're typing in your A, G, C, T into the keyboard, and you get this ugly tone. Anybody that's experienced that, like if you're doing old school sequencing, you'd be amazed at the quality of the sound that she did. She also created this glockenspiel music box because she had just done the Women in Tools program at Maker Labs. So she learned how to use woodworking tools. And so it was a hand cranked music box where the pegs were toned into the music that she created from the DNA sequence. So it was amazing. I'll see if I can find the video and post that, but it was a lot of fun. So I don't know if anybody else has any other fun things like that.
I want to hear about Craig's mushrooms.
Oh, he's in.
Yeah, I got a little 2-pounder maitake I found up in the Catskills this weekend. So I was going to process it, but I was so busy getting ready for Bio Summit. I'm like, well, might as well process it while I'm in the breakout session. So so it's maitake season. We found 15 pounds of maitake on one giant oak.
Wow.
It was like my brain didn't understand what was going on. Like, but yeah, definitely be shroomed for sure. But I'll share a little more about my work in a bit. I'm going to get back to this bird real quick.
Cool. Thanks.
Great to know we have some speakers already popping in. We are working together, others joining very shortly. Apologies for the delay, but I'm sure it's going to be a very interesting conversation so far. And then seeing how people are working beautifully with fungi and using it to make very useful stuff for in their various communities. Anybody has any other thing to share of how they are working with fungi? Thelma?
Yay! I want to share some experience with fungi, but for example, you certainly use them as biomaterials, but I use them for a completely unrelated thing, that is biodegrading plastics. And my fun story with fungi is that my research team and I went to a dumpster to look for microbes or any living organism that could be living in the garbage. And we found these amazing fungi that are capable of eating plastic. And then we took them back to the laboratory to explore their genome and to know how they degrade plastic and they use it as food. So this is awesome. And it's amazing because in our lab, our most valuable piece is literally a bag full of garbage with fungi, because that are the amazing most important part of our lab, because we totally want to know how they have evolved to make plastic their food. So it is awesome. It's awesome that maybe we can actually use them for example, a friend of mine is making fungi that can eat diapers of babies, and all that fungi are edible, and people normally don't want to eat something that comes from a diaper, but they can totally work as food for pigs or for cows or just as a protein source. So it is awesome to listen all the biomaterial side and also trying to think what else can I do with the fungi in my lab. So yeah, this is awesome because our most amazing part of the laboratory is just trash with fungi. So hope you enjoy this, and I'm really hoping to listen to your crazy stories.
Great. I think this is time we can spotlight Jameson. Jameson is in the room. He's one of our speakers. Wesley, do you mind spotlighting him? And let's have some few words from him while we prepare for these breakouts and have a more in-depth conversation on their amazing work.
All right, hello.
Yeah.
We're good?
Yep, just ask for an audio check.
All right. We were in the wrong room, so everything's all organized now. But I'm Jameson, and this is the team. We are from Norfolk, Virginia. So next slide up. And here is our team. And from left to right, here we have Chabi, Eric, Cristina, and Bobby. And today we're going to talk about fungus and connecting communities together with recycling different waste products. So there's a quote from one of my favorite people, Buckminster Fuller, and I really like this quote, and I thought it was very appropriate to our whole philosophy of what we're doing here. And I'll read it to you. Pollution is nothing but the resources we are not harvesting. We allow them to disperse because we are ignorant of their value. And that kind of brought us all together. And Buckminster Fuller is famous for a few things like the geodesic domes and stuff like that. So you'll see a little more about that as we get talking. All right, we're on slide 6 here. So we're from 757 Makerspace, and I'll let Cristina talk a little bit about our local community here.
So the 757 Makerspace is a workshop / clubhouse / co-working space. It's a place for collaboration. It's a place for community. There's a lot of community outreach that we do here. And all of us met through this place. We're all members here and active in this crazy place. And we've worked on lots of different projects together. And a lot of those things for us in particular led to fungi and mushroom hunting and foraging, and it was a common thread for all of us in the biohacking stuff and growing things on our own and learning from each other. So
next slide.
Yeah. All right. So this is a couple pictures of us out. So we kind of started being interested in mushrooms by foraging and wanting to bring home things that we could eat, things that were edible. We learned from each other. So with mushroom hunting, it's really important to correctly identify stuff and being able to learn from each other and go out together and when we find something new, being able to do research and making sure that we're finding stuff that's safe and working together.
Making new friends.
Making new friends and learning from each other.
You want the next slide? All right, foraging.
So one of the big things we like to do together, as Cristina mentioned, was to actually look for a lot of different mushroom species in the local area. One way to do that we've taken advantage of is just to take advantage of each other's knowledge on really cool spots where we could find potentially good stuff. Another way to do that is basically one thing I'll do is we'll look on Google Maps, look for nearby parks to in our local community, look for heavily wooded areas, anywhere where the mushrooms we're looking for might be located, and then we'll go there. It's one of the examples that, and usually we'll be able to find something. This is just like an example of a couple of our trips. Right here we have chicken of the woods. This is choice edible. You can saute it, tastes great, has lots of protein. This is shrimp of the woods. It's a really interesting parasitic fungus, if you read into that. And these are giant puffballs, and you can find these around this time in this area in Virginia if you just drive around and look at people's lawns. And so there's a huge variety of edible mushrooms that we can find nearby. But in addition to, Jameson, could you go to the next
Go to
slide?
slide, this one, the next one. 10.
Yeah, that one.
Identification.
Slide 10,
Yeah, so
next one.
Identification.
No, one after that.
Yep.
So in addition to edible mushrooms, we've been able to locate some potentially some medicinal and potentially some mushrooms with some other uses as well. And these are reishi mushrooms. We'll talk a little bit later. Talk a little bit more about these later in the lecture. But you can do some interesting stuff with them.
Tell them where you found this.
Oh, I found these in Norfolk, Virginia, just going for a walk. So you never know what you're going to find in your local area unless you get out there and look for it. And if you know what to look for, you'll probably find something cool.
So you were in the city when you found this.
Yeah, this is in the city, just off the sidewalk. So I also want to talk briefly about some resources for the identification of mushrooms that we found. So first off, Cristina and I used the first mushrooms we ate were some chanterelles that we found at a nearby park, and we used a YouTube channel. Learn Your Land was the first thing that popped up when we looked up for how to identify chanterelles, and it basically gave us everything we needed to know to be confident that what we were eating was not poisonous, which is very important to do so because obviously it's a potentially lethal hobby to take up if you're not careful or responsible. Another great resource is you can generally find a local mushroom identification group on Facebook, and we've taken a great advantage of that lately.
There was a question that came up talking about identification. A
Yeah.
couple people have mentioned the iNaturalist app,
Yes.
being able to help out. Also, word of warning, like with being careful. Do you guys have any suggestions or other things to add to that to be able to talk about?
That's funny. I actually just found the iNaturalist app like 3 days ago, and I already identified over 100 species of plants and insects. It's like the coolest thing I've been doing, and I highly recommend it. It's like Pokemon Go in real life. And yeah, the app I'm using is Seek, but it is with the iNaturalist. It's really cool. Check it out as a side note.
Your local Facebook groups are really great too because you can post a picture, take a picture of the underside of the mushroom and the top, give an explanation of where you found it because that can be helpful in identification, where you live exactly geographically, and you'll get a lot of experts weighing in. Make sure you read all the comments. Some groups are not as good as others at making sure people aren't making wild guesses, but you'll definitely get experts weighing in. They'll be able to tell you if it's safe or not safe.
And Eloisa brought up a good point that the iNaturals part is also connected to a real database that scientists are using inside of their stuff.
Right.
A few other great links inside of the chat. If you got feedback for the group that's presenting today, feel free to throw it inside of the chat. I'll make sure to pass these messages back to them, and we'll keep this moving along live.
Yeah, we can just kind of improv. So if you have anything to say, you want to be included. This is a community bio summit. Let's do slide 11. You want to talk about
Yeah,
this?
sure.
Yeah.
So here's a few pictures of just that show finding and preparing basically a chicken of the woods mushroom. And for this one, I just fried it up in some batter I made with some breadcrumbs and eggs, and it turned out great. So it's once you know how to identify the good stuff, you can really start benefiting from it.
Another good point to add is that certain mushrooms will come back in the same area year after year. So if you identify a tree that's supporting a large colony of, say, chicken of the woods, it's likely that you can go back there later on.
So leading on to the next stuff, being able to find those mushrooms and knowing how they're growing. Certain mushrooms need very specific growing conditions, and that's going to lead us to our lab here at the Makerspace and how we've learned how to grow here instead of out in a natural environment.
So there's different parts of the group that offer different benefits and different strengths. And that's what's so good about a community is everybody plays to their strengths and we can all pull together. And it's okay if you don't know what you're doing or you're unfamiliar with something. It's great to be an amateur. You just got to jump in, meet some friends, and you guys can start helping each other. And you won't believe how like rubbing two sticks together will get you actually pretty far, metaphorically speaking. So these guys mostly go out into the woods and do the field work and stuff like that. Eric, he does a lot of that, but he's kind of doing a little bit of both worlds, which is going to lead us into the second phase of our talk here. So I'll let Eric start talking about that. And next slide, number 12.
Yeah, so mushrooms are the fruiting bodies of mycelial networks, a vast underground structure that we usually don't see. And I think if you go to one of my favorite mycologists, Paul Stamets, he had some data that said like each step you take, you're stepping on like 3 square miles of mycelial network on just like one step, 1 square foot of soil.
Connects to that far?
Yeah, it connects that far. So you're stepping on a network that's communicating with trees and other plants that might be dozens of yards, if potentially not miles away in undisturbed ecosystems and habitats. So this photo right here that we see on the slides is just a photo to illustrate what the mycelium looks like as it's growing and consuming wood products and other natural debris. Can we move on to the next slide?
Yeah.
So in more of a cultivated, like sterile lab conditions, we can see how they grow in these almost fractal-like patterns, semicircles, branches, chandeliers, candelabras, and in learning a little bit of both worlds of not just foraging and identification, but also the proper sterile lab techniques and more hard science and cultivation, which kind of is a misnomer to call it hard science because it's actually pretty simple once you get into it and start understanding it. You can get stuff that looks like this on these slides. And what's interesting is that these patterns replicate and emulate themselves on larger scales. So if we go to the next scale, this is a picture that I found online of the city of Berlin lit up at night. And I think that this slide and the previous one have a great deal of similarity in how, the mycelium spread underground to find nutrients and how human civilizations, we spread around as well to facilitate the flow of electrons, to facilitate the exchange of goods and services. And there's a similarity here that is just absolutely fascinating from the microscopic level up to the global level.
Would you want to show some of your equipment?
Oh, yeah. So some of the equipment we can get, keep an eye out for Facebook Marketplace, Craigslist, any kind of market where you can get some of this stuff for super cheap, because who wants to buy stuff brand new and pay top dollar for it? This one is one of the most basic pieces of equipment. It's a pressure cooker, and you can use that to sterilize grains, sterilize other substrates, and make sure that it's completely sterile. Now, there's other sterilizing techniques involving temperature, various chemicals, cold pasteurization, but I like the steam one because you get a really deep penetration of sterilization techniques. So once you've got clean stuff out of this, you can then move it on to the next step, which would be, next product, a little bit of TV magic. You would put it into what's called a clean box, and we'll take that out. So it's just a plastic tub. In this one, I've made a modification to the design I saw. Usually they are still air, non-moving air clean boxes, and you just cut in some glove ports. But with this modification that I've done, it's actually a forced air clean box. So sort of combining the properties of a clean box and working in front of a flow hood. So using a little bit of duct tape, just put a tiny little air filter in there and you're good to go. And that really helps keep things clean from when you're sterilizing, or not when you're sterilizing, but when you're
hi, Jameson.
agar and working with spawn and that kind of stuff. You don't want contamination from the
Sorry to interrupt. Hi, Jameson.
Yes.
I think the participants cannot see if you are trying to demo a video or you are sharing something from your end. So if you mind, can you check on that?
Yeah, so we stopped sharing the desktop just so the speaker view would show up because we've got some live parts. If you're not able to see that, we'll switch back and run from the desktop as well.
Did you not see the video?
No, we didn't see the video.
Of the glove box? No?
No.
Okay, hold on real quick. We'll try to.
We can. What would you like to do?
Let's do that again.
Yeah, your camera is frozen on our end, at least on mine.
Okay, here, let's try that. Stop. Start. All right, you guys able to see us? Get movement?
No, it's like you're all sitting down. Oh, and it switched. Oh, it's off now.
All right, let's try this.
Okay.
Let's stop our video.
This is part of the conference experience.
Let's try 40G.
If not, we can just keep going with the slides and not waste time.
Let's run. All right, we'll just re-update this. All right, let's try this one. All right, we're gonna reactivate our camera. Give us 1 second. And if not, we'll keep moving on without it.
On the good side, your audio is coming through great.
All right, wonderful.
Excellent. All right. At least we have that part. All right.
Yeah, should we just keep going?
Yeah, why don't we keep rolling through the slides and
All right, so
Give me 1 second.
next we'll talk a little bit about Chabi is going to talk a little bit about sourcing actual materials as growing substrates to put into the autoclave and work with and grow your mushrooms and funguses on. So here's Chabi.
Hi. Okay. So a couple of the places, a couple of things that we've done and continue to do is partner with local businesses. The local lumber yard, we're collecting hardwood sawdust from them. We're collecting coffee grounds and coffee beans from coffee shops and utilizing those materials for our substrate materials. So we're taking businesses byproducts or waste products and then using them in our business model to produce food for the community.
Then the next slide. If you open the door from where we are in the Makerspace and you look straight out ahead, there's a brewery directly across the street. That's the top photo right there. Then if you look left, there's a coffee shop right there too. So we don't even have to walk far at all. And then we actually have a bicycle that has a cart on the front of it. And we can use that to go to some of the local businesses right here and pick up some of their waste products that they have. Yukon Lumber is another one that we have that just has a bunch of sawdust that we can pick up. So those are some of the local things, like literally next door, that we can go over and just get a bucket and scoop some grain out and get some stuff. Do the next slide, 18. So real quick, I'm going to go over how to make agar plates for this. I know a lot of people probably already know this, but I want to give an entry level to people who might get going on this and they don't know what they're doing. All you need is potato dextrose broth. You can order it online. It's not very expensive, and a little bit of agar. And right there is the recipe, and you can scale that up if you need. But I've scaled it down to be a small version. Just 6 grams of PDE, 4 grams of agar. You mix that together with 250 milliliters of water, and that'll get you about 10 to 15 plates. It says 10 to 13 on there, but somewhere in there. And that's probably what you need. And then that syringe is the actual spore inoculations. Next slide. So what you do is you mix it up, and then you autoclave it in the pressure cooker, and you have to watch it for a little while. It's about 250 PSI for about 30 minutes or something like that. Next slide. And then what you do is after you pour them, you put the lids on, and you don't quite close it. If you see on the picture on the far left, there's a little bit left open, and you let it cool like that. And once they solidify into like a gel, like a jello kind of thing, you flip them upside down and you put them in your refrigerator. And it's important to put them upside down so they don't get any kinds of yeah, what am I thinking of? The water that evaporates away. Condensation, thank you, that's the word. Next slide. If you do not add agar to it, you can do liquid cultures as well. And it's the same thing, and it's just in liquid. Next slide. Here we have a picture of Bobby at the brewery next door, and he's just going over there with a big jar, and he usually just scoops up and gets some grain. Next slide. So here we have a bucket of grain, and this is us actually putting them into different mason jars that we have. Next. And there's the inoculation ports on the top, and there's little vents on the side to help gas exchange so the fungus can breathe and things like that. Next. There's the inoculations, and then you want to put a little bit of tin foil over the top of these, so when you autoclave them, you don't get that condensation dripping down on you. Next slide. Here's Bobby and I just doing our thing on a Saturday, getting ready with some fungus and some grain that we got from the brewery next door. Next 27. That's here's me just doing my thing with some fungus. Here's slide 28. Here's a better example of how the mycelium grows over the fungus, over the spent grain that we got, and you can see it's like a halfway kind of thing. Next. Here's the total block. We actually have the block here. I would show you, but our camera isn't quite working. But the idea is you can grow mycelium into a block like that, and it can actually take different molds and different shapes and forms. And we'll get back to that in a few minutes. Next slide, 30. So if you grow it up in a dish, you'll get images like this of different mycelial growth patterns. Next slide. But don't feel bad if it looks like this. This is contamination, and this is going to happen. This is almost inevitable. You can't escape it. So just expect this, and don't feel bad if that starts happening, because you're a human and you can mess up, and you just want to have fun and keep this fun. All right, next slide. Here's a blower with a big motor and a HEPA filter, and just like Eric. Well, you didn't get to see it. Eric's got a smaller box. We're going to build a larger glove box with some of this equipment right here. And this is plans for our future. Next slide. Yep. So I want to show you guys what the simple workbench looks like and show you where this is located in our lab. So you can actually do this in a pretty dirty environment. So if we back out a little bit, you can see that's still the bench. And then if we back out one more, and you go on slide 35. This is off to the side. You can see it's next to a screen printing station and a bathroom, and a big industrial fan is overhead, and there's a washer machine and stuff. And so you can be in a very dirty environment and actually be clean and get clean results. So you don't have to have this extreme sterile lab. You don't have to have this fantasy place. You can do it in a very dirty, kind of dusty place that gets all kinds of sawdust and stuff floating around all the time. You just have to be careful with your procedure. You have to wipe everything down, make sure you know what you're doing and stuff, but it doesn't have to be absolutely perfect. And then next slide. If you pan over to the left, this is a view of the rest of the makerspace and some of the things that are in it. And next slide. You see in the corner, there is a dome. I'll let Chabi talk about this in a minute, but this is our dome, and then we'll go to the next slide, 38. Now, this is something Chabi's been building. And again, we like Buckminster Fuller a lot, and we really like his philosophy. So we built a dome. I'll let Chabi speak a little bit about that dome.
So the dome we built when we decided to utilize a dome structure because of its simplicity and efficiency of using floor space, and also it's very strong. And so through our process of learning and growing mycelium and using substrate, we're actually we're hanging bags of the inoculated substrate in the dome. And so it's been a really fun project to build the dome, and it gets a lot of attention. And it's portable, it's easy to break down. It was fairly easy to construct, and we'll be able to you can partition the space to have light rooms and dark rooms. And so where we're at right now with our project is this photo is about 3 days into the mycelium growing on the hardwood, inoculated hardwood substrate. And hopefully in about a week and a half, they'll begin to fruit. And these are brown oyster. These will be brown oyster mushrooms.
Jamie, one question that came up was back to the inoculation portion. Is there a HEPA filter that you recommend that's cheap?
No, we're trying to still do research on that. There are guides online to building HEPA flow filter rates. And what you want to do there's a real simple formula that you can follow, and it's the amount of flow volume. That's what you want, is a certain amount of flow inside your box. So you have to find a blower that equals a certain amount, and you can get the average size area that it's blowing over, and then you can scale your HEPA filter around that of the volume in the blower that you're making. If you don't know your blower, you're gonna have to do some math and figure out like the cubic feet per minute that it blows out of. I got ours, we knew somebody that's doing a lot of home construction stuff, and a lot of times in the spring, people will turn on their ACs and it doesn't work. People throw these things out, and a lot of time the actual motor is still good. Get a friend that knows electricity to help wire you in and stuff like that. But you can figure out, there are guides online if you look, and it'll tell you which one and how to narrow down a good filter. But you want it to be about as thick as you can get it, like a couple inches thick, like a big ceiling tile size. The bigger the better. And a lot of times you want to build it with a pre-filter in front of it too, like just to get a basic air filter for like an HVAC system. You want to put that in there so it catches all the dust and big stuff, because the HEPA is doing very microscopic things, and you'll clog that almost right away if you're just bringing straight air into it.
Yeah, and David brought up a good thing inside of here. Well, you definitely want to have a HEPA filter in there, a low-tech version in front of that. That filter, David had mentioned the 3M Filtrete MERV 13 in front of a box fan.
See, a lot of the community knows better. So if you surround yourself with people that know more than you, now you never want to be the smartest person in the room, and you'll always learn something and be connected to more people. Let's see, let's keep going. And
phase 3.
Yeah, let's go to 42? You want to do that?
Okay, yeah, sure, I'll talk about this one. So this is my buddy Kendrick and I. So this is our second go around with the inoculating substrate with the mycelium, and this time instead of using tubs, we've made our own bags with a heat gun, and this is just 3 mil, 6 mil clear plastic rolls that we've cut, and then we've used a heat gun to seal, make seams, and make these bags, and they're very strong, and it just helps keep out contamination. And then we've made some small slits, some cross-size slits with a razor knife, about 12 of them in each of the bags. And that way it will force the mycelium to fruit out these holes. and hopefully keep out the contamination, or keep the contamination down.
One thing I wanted to add about domes, the advantages of why we were using a dome is you can use the floor for different crates and stuff like that. And then obviously we were talking about the bags and your ability to hang. So you can control a lot of your environment and multifunction the space around it. Let's go to 43. Here's Chabi, and he's making more things inside of his dome, and we'll let him talk a little bit about what he's doing for this one.
So this was our first. So this is our first batch that we started. We got 6 different varieties of oyster mushroom, and so we had 6 different tubs, and we inoculated the hardwood substrate and had them in these tubs, and it. We found that the brown oyster was the most resilient of the 6 varieties, and we dealt with some mold contamination, and surprisingly there was some pink oyster that ended up fruiting.
Oh yes.
Even with the contamination, and so these are the fruits of our first go around with the mushrooms. And then there's the next, I believe the next photo. This shows the contamination that we got, but we still got some mycelium to fruit even with that contamination.
So some of the ideas that we're having is we want to create a closed loop cycle to where we're going around and we're taking waste products or resources that companies don't think they need and they're throwing away, using those as substrates to grow. And then not just growing mushrooms for the fruiting bodies, but we have different ideas that we'll explain a little bit more. I know we're running short on time here because we got a little bit started later, but we'll try to wrap this up real quick and speak about the production of what we're trying to do. So obviously, yes, we can grow edible mushrooms and medicinal mushrooms for different things. But one thing we were trying to do is use the mycelium to grow them in different blocks and different molds and different shapes. And you can use that for packaging. And there's a couple local shops around here that are advertise how they have 0 packaging and 0 waste products at their stores. And we're talking about teaming up with them to create biodegradable things that they could use inside of it. And that's one of the examples. Another example, this is a little bit off from mycelium, but you need to branch out and think about what people throw away and what are different waste products. So Chabi, he's been pioneering something with plastics he'd like to share with you a little bit.
So I don't want to.
You don't have any slides for this, but we can speak about it.
One of the things that we're working on is we're working with specifically number 2 plastic, the HDPE plastics, which is a very prevalent waste product, and it melts at a very low temperature, about 347 degrees Fahrenheit, and it fuses together very, very well. And so we're working on using an extruding method and also forced form method to repurpose this number 2 plastic and make structural members, to make containers for our various processes. And so it's one of the things, another one of those, taking somebody else's byproduct and then turning it into products for other means of production and use.
This plastic is actually very strong. We were talking about testing different like chairs and furniture to actually kind of like 3D print with these waste plastics and stuff like that.
Yeah, there's companies over in Europe. They had been making furniture with the HDPE plastic, and there's companies out there that make larger scale production equipment that takes the number 2 plastic, grinds it up, melts it all, and forms it to make lumber and various structural members. Yeah, like the Trex planks and stuff.
So one thing we're going to try to do is use some of that plastic to make our different molds and shapes for the mycelium substrates to grow inside. So you kind of, this is where it gets cyclical, and you use your stuff to build your stuff with more stuff. And that's very scientific. And some of the things we actually want to try is see if we can get some of the dome covers made out of this plastic. So you could make some more of the actual larger structures out of recycled trash materials as well. So a lot of our concepts that we're still a work in progress, but we're trying to figure out how we can use more of these resources to build our own structures and build our own tanks and containers and forms to make more products to sell back to these local businesses. And a lot of times there's local farmers markets and local like shopping kind of things like that where a lot of people come together. And this is where we can connect businesses together. And a lot of times they won't know they're even connected if they're being shared by waste resources and things like this. So what we were trying to do today is show you guys that there is a model that you can start in your own city today. You can try to locate some waste products that a local business is getting rid of, usually a biological substrate. Find some friends that you meet, and you'll meet more as you go along the way. But meet some friends that are into mushroom foraging and stuff like that. And they'll be real interested that you want to actually try to grow some. And then you guys can start teaming up together. And then go to some of your local businesses and see how you could help them with the product as far as giving them a packaging or reducing their waste somehow. And all of a sudden you'll start connecting businesses together, and you'll start building a community that's thriving because you're reducing waste products, you're generating commodities right there on site, and you're having a lot of fun with your friends. And that's the most important part, is to have fun with your friends and not be afraid to fail and to learn something new. And as long as you're not really eating dangerous mushrooms, you're not really going to do anything other than get contamination. And like I said, just expect that. Chabi was showing that you got contamination and still have fruiting bodies. But don't be afraid to fail, and just know that you're going to fail. And if you don't, you're not challenging yourself enough, and you need to go forward and keep trying. So that was, I know we're probably right at the end of time. I think, how are we doing on time? So I guess we'll open it up if we have any questions in the chat that you can send to all of us. And I know our video is not exactly working. Oh, wait, we have more slides? Oh. 48 and 49?
I don't think we have them on here.
Oh, okay. Well, we'll open it up to you guys if there's any questions in the chat, or if there's anything you'd like us to clarify or go over more. Please ask now.
And the camera's back up.
Oh, and the camera's working. Hey.
Ooh, nice. Craig showing a nice big giant batch there. A couple of comments that came in. They were talking about 3D printing with mycelium. There's a couple people that have been working with that.
Oh, wow. With the live mycelium?
Anik, I'm 3D printing with mycelium. MOGU is a great furniture company. A few people have mentioned them.
Write that down. Okay. Thank you. Yeah.
Reiterating one of your things, make stuff from more stuff. Scientific, high quality comment. A few people working with 3D printers and a global initiative for plastic stuff as well.
That's awesome.
There was a question about using the heated extruder to kill the mycelium. I don't know if anybody on the team has any experience using a 3D printer yet with that.
We're working with our metal friend to actually build a nozzle right now, and we actually haven't gotten into the R&D part of that yet. But that's a really good thought. I haven't thought that's interesting.
Sounds like it might be more like the clay situation. We don't have to heat that up. We really just need to get the mix right enough to be able to push it out by using the motor to extrude that.
Just extrude without heat.
Without heat.
Yeah. Okay, that's neat.
I had a question.
Yes.
So if I'm like out in the woods and I see a nice fungus I like, and I've gone through the process of identifying it, and I know it's good, and I want to take it home to eat, is there a way of extracting it? Are there things I need to be mindful of to be like environmentally conscious when taking that mushroom or that fungus out of the ground or out of the tree?
Yes. So Eric mentioned that mushroom's going to come back on that same tree every year for a lot of fungi. You can get very specific and have a mushroom knife, a fungi knife. You want to cut it cleanly.
You don't want to damage the mycelium.
You don't want to damage the mycelium, so that mushroom will grow back in that same spot the following year. Also, mushroom fungi spread by spores. So a lot of people like to use a basket instead of a bag. So when you're taking it home with you, you're spreading the spores around in the woods and you're growing more mushrooms instead of just taking what's there and not leaving anything behind.
Or if you use a bag, make sure to use a bag that is perforated so the spores can fall out and as you walk through the woods.
And don't take all of them, please.
Yeah, with regards to not taking all of them, this applies not just to mushrooms, but to plant foraging as well. It's the below 50% rule, and I think it's more like the 20-80 rule, where you just want to take a little bit for what you can use and then leave the rest to do its function in the natural environment.
Great. I think this was a really great and very interactive session. I think we have we have a question from Anik. Your hands are raised. I guess you have a question for Jameson and his team. Please go for it.
Yeah, it was just on the how the 3D printing would work. You print the substrate. So I'm doing the sawdust mixture. So you kind of want it to like be liquefied or moist, and then have it go through the extruder, and then the fungal spores grow on it. So it's not like the fungus goes through the printer. It's more so you're printing the substrate. So.
Awesome to know. Thank you.
There is also a great new book just recently out called Entangled Life by Merlin Sheldrake that everybody will enjoy. Yeah, look up Entangled Life.
I'm writing that.
Yeah, we're lucky here at the Makerspace. We've got experience here with 3D printers and people that know how to use them and build them, and it's a good spot for money and stuff like that.
Hey, Derek, I thought that was you. How you doing? Good to see you.
Great, Jameson. Yeah, awesome session. Good to hear from you.
I thought that was your voice. Yeah. Thanks, guys. Well, I think that about wraps it up. And I know we're a little bit over on time, and we had a little bit of technical difficulties there in the beginning. But I think we're all good. So that's that. We'll wish you guys well, and you guys should start up your own fungal community back at your town, and like I said, start digging around in the trash, find some garbage, and find some friends. Yeah.
Jameson and Tim, just before you leave, we want to have a quick family photo. So Wesley, over to you to give us some family photo.
Yes.
Okay, sweet. Yeah. If we can have people, if your camera works, please get it up for us. I'm just gonna take a screenshot, basically.
Yes. Awesome.
And everyone fits on one screen. I'll give everyone a second to get their cameras on.
Everybody say fungi.
Okay. Everyone say fungi.
Fungi.
Hold it. Got it. Perfect.
Awesome.
Great. I think this was really an amazing session. And right now we are basically into wrapping up the entire sessions for today. I think it's been a very great Power of Community track session. We've had presentations earlier this afternoon on how to start and sustain community labs. We went on to various talk sessions, and now we just ended the breakout sessions that featured how to work with fungi and creating a whole community of around fungi. And I would want to open it up at this point to listen to what your general takes are on everything that happened here today. I see Craig Trester with some amazing gifts for us. Shall we have you?
Yeah, processing 2 pounds of maitake. So found 15 pounds of it on one oak tree up in the Catskills in upstate New York. Yeah, my brain didn't really understand what was going on when I first saw it. So getting ready to dry my mushrooms up. So I think it's really serendipitous. Yeah, definitely stay in touch with me. I love what you guys are doing. I think it's awesome. You got all these little myconodes popping up all around the world in little communities and cities. I think it's working with fungi and soil is the best shot to really healing our world. So awesome presentation, y'all.
Thank you.
Thanks.
Thank you. And
Thanks,
Great, 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 great.
Hey, Jamie, before we conclude, and I know we're short on time, where can folks go to find more information for like social media purposes?
Sure. So be sure to look up our Makerspace. It's 757 Makerspace, and we do a whole lot more than just fungus, but that's our focus for today. We have a warehouse at the size of a block, and we have almost every tool you can think of in here. So look us up, reach out to us, come down and visit us. I'd love to give you a tour and meet you guys. And feel free to reach out and ask us questions. Even if it's not fungus related, we probably know somebody that can get you an answer or has a very specific talent in that thing. So we extend our community to you.
And if anyone has any other questions, you can also direct them to me at Bramble Patch Creative on Instagram, where I post about art and mycology and herbalism and nature studies and all that kind of stuff.
Awesome.
Awesome, guys. Do we have any feedback, any questions generally about this session and the others that we've had? I think this is the time for us to be more interacting and engage and just sharing your general thoughts, what you've learned, what worked well. I mean, this is the time. I think this is something that we haven't seen before, but we are doing so well with that. So it's more of an open discussion now, and let's get the conversations up. Thank you.
Can I say? Are you
Please
guys
have it.
listening?
Yes.
Yeah. Well, I have two things to say. The first one is that I'm loving all the sessions. My day has been like getting into meetings and getting out so I can see others, because there's so many interesting stuff that I can't. Oh, was that?
So we can hear you.
Hey.
Yeah,
Am I back?
Yeah, you're back.
Yeah, I can hear you. I think that yeah, perfect. I think my PC has frozen, but it's okay now.
Okay.
Yes.
So what I was saying was that two things to say. The first one is that it's been such really fun to participate in this virtual bio summit. It's been kind of messy sometimes because I'm always, my day was like getting some meetings and then like getting in and getting out, so I can kind of get to know everything that's going on. But I feel super like, I can't believe I'm good. I think you all guys are incredible. And yeah, so no complaints. And the second thing is that it would be really cool if the Bio Summit had like document page with all the social media of the participants, maybe sorted like by the panels. I don't know, because it's really good to keep in touch with people, and maybe, and sometimes at the gatherings we don't have that time to share our Instagrams or Facebooks, something like that. So it's really cool to keep in touch with the projects and the ideas. So that would be my suggestion.
Great. Thank you very much for those useful insights and the comments. Just a quick one. I think there was a question here in the chat from David, and he's asking, is anyone working on getting medicinal metabolites from mushrooms?
Sure. So that's something that my interest particularly speaks to with regards to medicinal mycology. A lot of mushrooms, it depends on the species and how tough the tissue is. Let's take reishi as a good example. Because it's so tough and woody, you have to chop it up fine and make a double boiled extract out of it, or a concoction.
Sorry, we can barely hear you because it looks like you're distant from the mic. Your response is a bit faint.
Speak up a little bit. Yeah. So with medicinal mushrooms, can you hear me now? Is this tone okay?
I think it's quite better from, yeah.
Better, okay. So regards to extracting the medicinal properties of certain mushrooms, we'll take reishi as a really good example. Reishi, the mushroom of immortality, lingshi, it's got lots of different names. Because it's such a very tough and woody mushroom, it's typically chopped up very fine and slowly simmered or double boiled into a concoction. Depending on what you use to extract the medicinal properties from the mushroom, you can use water or vinegars or alcohols or olive oil or glycerin, and all of these will extract different properties of mushroom. So there's a lot of research online on how to do like basic herbal formulations, and those also apply to mushrooms in terms of making a tea or making a tincture or drying it and powdering it for later use.
Great. Thank you very much for the insight to that. Do we have any other questions, general comments, and feedbacks on the sessions that we have had so far? I think just for a quick recap, one thing that I want to share with this group, which came up during the presentation, was that just generally for the purposes of science communication, as scientists and as people who are trying to promote and democratize the work we are doing, it would be good to tell our science stories not only in the papers, but usually also trying to communicate outside of this media, just to ensure that it reaches the people who are generally promoting our work. So that I think is one thing that we should take a very keen interest in, and that is one thing I personally had picked. Yes, and I think this session for me personally had opened my eyes to some of the amazing works each and every one of you are doing. And I can only say thank you on behalf of the BioSummit organizing team for the Power of Community track, for putting a lot of effort for making this session a very successful one. And to all speakers, you are all amazing. And thank you very much.
Yeah, I think Anik raised her hand.
Yeah, no, I want to say it's so nice to meet all of you. I'm currently applying for Fulbright, kind of trying to see how Acetomides fungi can be introduced more into factories, into our industrialized systems. And I've only ever approached this through citizen science. I'm part of GenSpace. Craig, it's great to see you. Craig's been a big help in my fungal track. So it's so great to meet you, and I'd love to connect. You can reach out to me in pretty much any social media form. Just look up my name, and I'll come up. So thank you.
Yeah. So what was the mushroom that you're trying to introduce again?
So from the Acetomides branch, but sac fungi.
Perfect. So this session is due to close in about 10 minutes. Feel free to hang around and just have a chit chat. And just discuss anything that you think we want to. I think officially we are due with the last session, and I think it's been a great one. Yes, thank you.
Thanks so much, Harry, for moderating. It's been a very good session.
Yeah, thank you.
Yeah, thanks, Harry. Thanks everyone for coming.